everybody. In this video, we're going to continue our exploration in polynomial identities and how to factor them using the identities. So how can you use the polynomial? We're doing example 3 from lesson 3, topic 3. How can you use the polynomial identities to factor polynomials and simplify numerical expressions? So we have 9m to the 4th minus 25 n to the 6th. So first thing I need to do here is I need to identify what I'm working with. The first thing I notice is that I have a subtraction. So I know this is a difference of. Now the question is what is it a difference of? Well, I'm going to look at my exponents here. If it's a difference of squares, I should be able to divide each of my exponents by 2, and I can, so that works. But if it's a difference of cubes, I should be able to divide by 3. And again, we want the simplest form, so we're going to see which higher value we could divide by. So in this case, 4 cannot easily divide by 3 and give us an integer number. So I'm going to go with difference of squares. Okay, my a value, because remember it's a squared minus b squared, my a is going to be 3m squared. And I got 3m squared by taking 9m to the 4th, and I took the square root of that. And remember, 9m to the 4th can be divided into 9, the square root of m squared times the square root of m squared, which gives us the square root of 9 is 3, square root of m is m times m, which is 3m squared. Right, my b, so I'm going to put a equals. My b equals the square root of that, which is 25n cubed. Again, I just basically divided those each by 2 to get these values here, because again, the square root is that power to the half. So we'll get into that when we get more into exponential properties. Oh, I said 25. This is 5. I was just looking at the 25 and I thought 25, and I did not write down this 5. All right, so now we have my a's and my b's. So 9m to the 4th minus 25 n to the 6th is going to equal 3m squared plus b, a minus b, plus 5n cubed times 3m squared minus 5n cubed. And there we go. And they pretty much did the same. So could we write the expression as 3m squared plus 5n cubed times 3m squared minus 5n squared. Let's go on to the second one. How can you use polynomial identities to factor the polynomials and simplify the numeric expressions? So we're going to look at x cubed. Again, the cubed is going to be really hard to divide by 2. So 1, I have the difference of. And in this case, 3 divided by 2 will not give me an integer. So 3 divided by 3 would, so difference of cubes. All right, so the difference of cubes is a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. Okay, so now I just need to identify what a and b are. So a is going to be the cubed root of x cubed, which will just be x, and b is going to be the cubed root of 216, which I believe is 6. Okay, so now that we have a and b, I'm going to look at, so basically it's like this, x cubed minus 6 cubed. This is going to equal x minus 6 times x squared plus 6x plus 36, because again, 6 squared is 36, and there we go. X minus 6, x squared plus 6x plus 36. Oh, let's look at the common error. The second factor is almost a square of a sum. Remember that the middle terms of difference of cubes identity is the product of a times b and not 2ab. All right, so there you go. So how can you use a polynomial identity to factor the polynomial and simplify the numeric expression? I mean, for this next one, you'd say like, oh, we could put it in a calculator, but what if we don't have a calculator? We want to figure this out by hand. So this is the sum of cubes. And that's a U. That U came out a little bit odd. Rewrite it. And the sum of cubes is going to be a cubed plus b cubed equals a plus b times a squared minus ab plus b. So in this case, my a is going to be 11. My b is going to be 5. So I'm looking at 11 plus 5 times 121 minus 55 plus 25. Oh, I forgot to put the squared here. Squared. Okay, what is that? That is 16 times 121 minus 55 plus 25. Let's see. 55, 25, that's 0. That's 30, so it's 121 minus 30. And then we have, what is that? That's 91. And then again, I'm doing this by hand, so I have 91 times 16. 6 times 1 is 6. 6 times 9 is 54. 91 here. So that's 651450. I mean, I don't even know where I got the 0. 1456 is my answer. So there you have it. You're going to say, well, if I have access to a calculator, why do I have to go through all that work? I don't know. Sometimes you might not have access to a calculator, and then learning these identities and learning how to solve it. I mean, I know they're on your phone, but learning how to solve it by hand can come in handy one day. All right, so guys, we have to try it. So use a polynomial identity to factor each polynomial. You have 3 of them. Use those identities. Good luck, and I will see you in the next video.